Oh, wow, this is very bright. I can barely see y'all. But you know what? Catch me after the break, because I do want to meet as many of you as possible. I really love meeting new people. That's why I speak at conferences, actually. It was always a hack for my social anxiety. So now you have a reason to come and talk to me. And yes, I don't have pink or long hair anymore. Sorry. I do have short blue hair. So hi again, I am Jenn Creighton. I am a senior software engineer at Netflix, where I work on the NodeJS Platform Team. I am very active on Twitter. My handle is girlcode, girl with a U. So you can also feel free to reach out to me there if you don't meet me in person. Okay, so as you know, this talk is focused on debugging async JavaScript. And there are various focus areas of this talk. Much like asynchronous JavaScript, we're not going to be going in order, but we are going to hit on these topics. So, why is debugging asynchronous code so difficult? I think it's actually particularly tricky, and there are some reasons for that. Now, what common pitfalls can we avoid when writing async code, right? Helps us avoid bugs in the first place. And then, what are some debugging options when something's gone wrong? So how can we figure out the problem? Now, to kickstart these topics, I'm going to be showing some examples of async bugs. And if I show you the code and you don't know what the bug is, that is totally okay, all right? This is not a quiz. But some of you are going to know. You're going to know immediately what has gone wrong. And if that happens, I want you to do something for me. I want you to ask yourself, how do I know that? Not why is the bug happening, but how do you know? I'm going to come back to this, I promise. So, moving on, let's get started looking at some code. Now, in this scenario, we are tasked with retrieving a config file and validating a property on that file. Now, our coworker has let us know that there's a function we can pull in to retrieve the config. So that's what we're going to do. We import the getConfig function, we call the function, expecting it to return the new config. Except it doesn't. Okay, we get undefined. What the heck is going on? Now, the first thing that we're going to do is we're going to look inside of the getConfig function. We're going to see what it actually does, because no, there is no documentation. So here is what we discover. getConfig takes a function, it reads the config file, receives back some data, which is the config file, and then calls the function with that data. Okay, this does not work how we expected it to, and to be honest, it kind of sucks to have to pass in a function, so maybe we can modify this to return the config like we expected. So to do that, we're going to create a new variable. We're going to assign the data to that variable. And then we're going to return it. All right, let's run this. And, ooh, okay, yeah, no, still undefined. Okay, this example is very loosely based on something that happened to me like not that long ago. I've changed several of the facts. But I did need a function that retrieved a config file. And when I ran it the first time, I did get undefined. But unlike this example, when that happened, I actually knew what caused the problem immediately. And I would not be surprised if you knew immediately what caused the problem here. But again, how do you know? Just hold that thought for a little bit longer. Because in this contrived example, we don't know, right? We're trying to find out, which means that we need to debug. And when I need to debug, I reach for console.log. Okay? Yes, please, let's hear it for console.log. It has served us well, okay? I think it is great, genuinely. I use it all the time. There is zero shame in console.log, okay? It is a quick option to get some more information and help you debug. And I am going to show the debugger in a later example. I really love the debugger too, but the debugger is it's a separate tool. And we choose the tool for the job, okay? That is just as true in debugging as it is in writing code. And for this job, console.log is perfect, all right? I just want to know what's happening in this function, right? I want to know what is the value of the data when it's received, and what is the value assigned to the config variable. And as I'm doing this, I expect these logs to happen in this order. 1, 2, data, config. When I get those 2, 1, so the config is undefined, and I do get the data, which is an empty object. I expect that my config file at this point is just a dummy object. I'm just using it to fake this for the testing. And again, if you don't know why the order is off, that's fine. But this would be the point where if I didn't know what was going on before, now I actually do know. Because this is where I realize that this code is not synchronous. If I didn't know before, now I actually do. How do I know that? I've seen this before. And I found that actually most of the time the answer to that question is, I've seen this before. I've worked with it before. And if you knew, that is likely the answer you also came up with. If you've worked with Node to read a file, then you know that read file is asynchronous. So in the real version that this example is based on, when I called getConfig and received undefined, that's how I knew what had happened. I've worked with Node before. I realized that the function was using read file, and I had mistaken an asynchronous function for a synchronous one. Or maybe you've worked with asynchronous callbacks before. I say asynchronous because not all of them are, but that could have been the information that really clued you in here. Or maybe you didn't know until you saw this. This is a really big clue. It's something that I have internalized through years of debugging. An unexpected order means some code somewhere is asynchronous. And knowing that is really half the debugging battle, which is why debugging asynchronous code is tricky. You might not even know it's asynchronous. You might write code like this, not knowing that read file is asynchronous, which let's just step through this really quickly so that we are all on the same page about what's happening here. The config variable is created, and then we call read file. Since that is asynchronous, it starts, but it doesn't actually block the next line from executing. And that next line returns the config variable, which was never set, and so its value is undefined. And then meanwhile, read file receives the file and calls the callback, where the data is assigned to the config variable, but it just doesn't even matter because the outer function returned in the previous step. So that's how we get an undefined config, even though the file is read and the data exists. But we're not waiting for that data, and that is the bug. And notice that at no point did we get an error message. Why would we? This code is incorrect, but valid. So bugs, they can be broken down into a few categories, and some are more difficult than others. So syntax errors, those are really quick fixes. Runtime errors, maybe not as quick to fix, but you usually have errors along the way to help guide you. But this, writing code that's valid but incorrect, this is the most difficult category to debug. Here's another example. We're going to undo our past work on the getConfig function, get reset. And instead of attempting to return the config, we're just going to wrap read file in a promise. Now, a quick note that we could also use read file sync, which is actually the synchronous version of read file, or in newer versions of Node, a promise-fied read file exists. But let's say that we can't use the sync version and we're stuck on an earlier version of Node.js. It happens. So we're going to have to actually do the legwork ourselves, which really, it's just not that much. We just need to return a new promise that resolves when we receive the data. Really, it's not that difficult. And then let's run this. Let's see if this works. We're going to call getConfig. We're going to attach a .then handler, which for now will log the config to the console. And then when we run this the first time, we're going to see, OK, undefined. Here's the thing, though. This should work. That code should actually work. So once again, handy-dandy console.log. Let's see what the data is. OK, the data itself is undefined. And knowing this, I'm going to check that the config file exists. And it doesn't. So it turns out when I did git reset previously, I accidentally undid the config file as well. I accidentally removed it. This has happened to me before, and it is obnoxious. OK? But did we get an error? I don't know. Let's log it out and see what is there. OK, yeah, this makes sense. No such file or directory. Which, by the way, I want to note, that's actually not the bug. The missing config file is not the bug. The bug is the silent error. When I wrote that promise, I made a really classic mistake. The promise resolves with the data, but it doesn't reject. So when read file can't find the file, it should return an error. But I don't know that. No one knows that, OK? Silent errors are the worst. Something has gone wrong and nobody knows. And they're super common in async JavaScript. Again, that code is valid code, and it works as long as there is no error. So knowing this, let's fix our promise so that the error actually surfaces this time. We'll need the reject function, and we'll use an if-else to decide when to resolve and when to reject. So if there's an error, we call reject with the error itself, else we're going to resolve with the data. Let's see if this works. We call getConfig again. But instead of a .then, we're going to attach a .catch, which will catch the error, and then we will log a more helpful message to the console. And when we run this, we get not undefined, finally. OK, great. The promise is rejecting. We catch it. We log the error message. This looks good. So always reject. OK, it is a best practice. Follow it. It will actually make debugging promises easier for you. But I should note that there are so many options for error handling to go wrong in asynchronous JavaScript. These bugs often fall into that valid but incorrect category. Let's look at another fun/infuriating example. Let's say we're building an application where a user can RSVP for an event. So that's actually what the function RSVP does. And it also returns a promise. And it's already handling errors. It's got a .catch attached. And our current task is to add some UI that shows a schedule of the user's various events. So we're going to add a .then handler so that once RSVP resolves, we'll update the UI. OK, this is and is not what we should be doing. We do need to do something like this, but written like this, we've actually created a bug. Now, unlike last time, I'm not going to reach for good old console.log. I still love it. But I do think there's a better tool for this job, and that's the debugger. I really love the debugger for async code because it really helps to offload the mental weight of thinking async. So there is an extra mental tax when we write or debug async code. So as humans, we are very inclined towards events that happen in order, one after the other. So A, then B, then C. A, then B starts, then C, then B finishes. That's a bit mind-bending. And with logging, you're actually still doing those mental gymnastics while also keeping track of what got logged when and at what point. And at some point, the mental tax is just really too high. It's really no longer effective. And this is where the debugger can help. So unlike logging, the debugger can pause execution. And that allows you to inspect the state of the application at a certain point. And then from that point, the debugger can step through your code line by line. And that allows you to step through asynchronous code as if it were synchronous. So we're going to take a look at this in the Chrome Dev Tools. And at first, I'm going to show you the case where this works, where the code is all fine. So under the Sources tab, I have selected the file where this code runs, and I'm going to set a breakpoint on line 15, where the RSV function is called. So I set the breakpoint. I'm going to click the button. This will run the code, which will hit the breakpoint and stop execution. And then I'm going to start to step over the code. And stepping over it will run the code inside functions, but not take you inside of them. So I'm stepping through execution. And I can see here in my call stack that promise.then did get run. And then what I'm actually going to do is I'm going to actually step into that function so I can check the add to event and see that it got the correct ID. So that looks good to me. And then I'll just step through until the program executes. And as you can see, the event is added to the list as expected. So that is the case where this works. And now we're going to break it. So I have modified this code so that the promise returned from the RSVP function is actually going to reject. So what I expect is that the .catch is going to run and the .then is ignored. All right. So we're going to be using the same breakpoint. We've clicked the button. We're going to start to step through the code as we did before. We can see that the .catch is hit. OK, great. That actually happened the way we expected it. Step through again. What the heck? OK, so we're in the promise.then. So it's actually being hit. So what's actually happening here is that the event is being added to the calendar, and we're also getting an error message at the same time. So that is the bug. So this is another example of valid but incorrect. And look, it is not unreasonable to assume that because .catch is ignored when a promise resolves, that .then is also ignored when a promise rejects. That's actually true. But it's also true that the order matters. And so any .thens after a .catch will still execute. And so to fix this, we actually just need to flip them. When the promise rejects, like now after the .then has been moved above, then it'll be fine. But previously, we were having the bug. Now, I don't really have time to cover all the options and intricacies of error handling and promises. This is actually just one example. Or in async await, because error handling is different in async await. Async await is a very strange but lovely addition to asynchronous JavaScript. It can make writing async code much cleaner, much clearer, but it can also introduce some issues. So for example, here's some promise-based code, and we might want to convert this to async await. And so when we do that, it might look like this. So an async function awaiting promise 1 and 2. Now, the problem is that the promise-based code from the previous slide and our async await refactor are not equivalent. This actually might be fine, but we've taken code that didn't block. So the promises in the previous example actually ran in parallel, and we've modified it to block. So await blocks until the promise resolves or rejects. And so this refactor actually might have some unintended consequences. Promises and async await have some really core differences, but I would say this is the biggest one. Promises are non-blocking. Async await can be both blocking with await or non-blocking. So await is not required to run the promise in an async function. And also, async functions return promises. So this intermingling of async and sync is why I call async await strange. It's really that same mental tax I talked about earlier, and it can really be a lot. It leads to a thing I call what does what and when and where, which means you need to be familiar with all the ins and outs of different async structures in JavaScript. So you need to know everything about promises. You need to know about async await. You need to know about callbacks, and you need to know about set timeout. And keeping this all in your brain all the time is impossible. So mistakes are bound to happen. Here's another favorite of mine. I've written a tiny little application, and it just fetches some posts and lists their titles, except I'm not seeing the data show up in the UI. So the first thing I'm going to do is I'm going to go to the network tab, and I can see that the data actually is coming back. So that means something is wrong in my code. We're going to set a breakpoint, and because I know that the data is coming back, I'm going to pause execution at line 12. I just want to make sure that this was set properly. So as I do that, I'm going to refresh the page, which will hit the code, which will cause the breakpoint to be hit. And you can see that results is going to be undefined, and I actually expect that because I haven't stepped over fetch post yet. That will actually run the code in fetch post. And then when I do that, I can see that results is now a promise. So I've done something sort of silly here. Async functions return promises. And sometimes when I'm working with async await, I get so used to what it looks like inside of the async function, where you can sort of treat promises as if they're synchronous, that once I start to use the async function, I just kind of get my wires crossed and I forget to switch back into promise mode. So yes, I've made this mistake more than once. It really drives me up the wall. So I'm going to fix this by calling fetch posts, which returns a promise, and attaching a dot then, where I will set the post, and now we are good. But as I said, I've made this mistake more than once. Not because I don't know that async functions return promises, but because, again, this is just all a lot to keep in your head all at once. The good news is that I'm able to debug this relatively quickly. If I didn't know why this happened, and if I hadn't had this experience before, this actually might be more difficult to debug. Which brings me to the one debugging tool I haven't talked about yet, and it is the best one. And no, it's not TypeScript, or a linter, or tests, even though those are all good and helpful. Your best debugging tool is knowing something well. And knowing something well really cannot come from memorizing the spec. Knowing something well is about experience. So going back to the start of that talk, that question of how do I know, I said that the answer is often comes down to experience. And I really want to add on to that, because going a step farther, that experience might be, I've worked with Node, and I know that read file is async. Or it might be, these logs aren't in the order I expected. And that first one, I know read file is async, that is just straight knowledge, right? That is still really important in debugging. But that second one, how do you build up knowledge like that? So it's not in the spec or the documentation. That is really hard-earned knowledge from seeing things go wrong. And as you go along in your career, and as you debug, you will naturally start to build up that knowledge. But if you are struggling with a concept in particular, like say, debugging JavaScript, async JavaScript, I suggest be the bad dog. Okay, first. On a personal level, I believe all dogs are good dogs. Okay? Just want to put that out there. But this concept was introduced to me by a yoga instructor. So she wanted to teach us the correct alignment for a pose. And so she would teach us the correct alignment for the pose, and then she would tell us to be the bad dog. Or in other words, do the pose incorrectly, with the incorrect alignment. am I now perfect at yoga? No, though my Warrior 2 is really good. But I do know what it feels like when the pose is off and I can start to adjust. I get that same value out of applying this concept to code. I have struggled with async JavaScript before, and it was because I realized like all the tutorials I was reading, everything I was looking in about the spec, like those were all good and helpful, but I didn't actually know what anything looked like when it went wrong. So it was never, those tutorials and things, they were never being the bad dog. I never saw what it looked like when things went wrong. So if you're struggling or you want to learn something really well, be the bad dog. Learn all the ways it can go wrong, what those look like. You will still make mistakes, and there will still be bugs, but it will be easier to find those mistakes, fix those mistakes, and isn't that what we all want? That was a lot in a short amount of time. Thank you for listening and for being here. See you after the break.